let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
actually
in
a big piece of
What is that process that a developer, or let's say
As the Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am the host or co-host. I gotta quit saying hosts because you're here permanently, Johnny. You're not going anywhere. But I am co-host Andrew Sullivan, joined as always by my friend and compatriot Johnny Rickard.
What's up, man? How's it going?
Happy Wednesday. It's I was saying this when we were getting started. It's slightly disorienting to be streaming from the tower. You can kind of see up here no, I can't. I don't know how to move my hand and actually point at. There we go. This is the edge of the conference room that I've bogarted here in the tower in order to stream. But yeah, I'm in the tower this week doing a face-to-face with our product marketing team for OpenShift. Lots of interesting stuff going on. So
Nice. That's awesome.
yeah, it's kind of funny. What was it? A month and a half ago, my team, so tech marketing teams, we all got together and we had, basically the same thing. And it's funny to see the difference in just the type of people that do the different things. Like, we're going through doing introductions, and of the 30 or so tech marketing people, there's like 5 who do home brewing, and there's another 6 or 8 that do like cars, like they tear apart cars and put them back together, or do muscle cars, or all this other stuff. And
yeah,
the marketing folks are not like that. They are largely, they social people. They like to go out and be around other people instead of, hiding in garages with dirty hands and stuff like that. So I can't fault them for it.
It's always interesting to see especially like you think Red Hat, bunch of nerds, like you're not going to have a bunch of there's not going to be people that like sports, or there's not going to be people that like cars, but there's just such a variety of personalities there that I think you have a little bit of everything. I have a really great friend that loves hiking, and that's what he does. Like he's out exploring America right now. So yeah, it's funny to see the different personalities that we have.
Yeah, well, it was funny to me because basically every one of the marketing folks was like, yeah, I love to do travel. And the tech marketing folks, I think because we travel so much, not nearly as many people said that, which was another one of those differences. Like, in the before times, I traveled a lot. I was traveling, depending on time of year and all that other stuff, anywhere from 60-70% of the time. And now it's now it's more like 15%, maybe. So,
dang,
yeah.
I didn't realize you guys were traveling that much. That's insane.
Yeah, well, it used to be conferences. Part of tech marketing is quote unquote evangelism. So we every conference that it was relevant, I'd submit a session or 2 or 3, and so we end up going to conferences, or we'll go out and do customer visits and stuff like that. One of my peers is going on a road trip, if you will, an airplane trip, I guess, because they're not actually driving, but going to see a number of different customers across the EMEA region. And it's one of those, they started with 2, and it was, hey, well, I'm going to be in the country, or in the continent. Is there any others that we can see? And it's now turned to 12. Oh
man, that's awesome though. That sounds like a good trip.
Yeah. I miss doing those, but at the same time, I did a whirlwind tour of Australia several years ago, and it was like I left on Friday. My first stop was Wellington, New Zealand. I arrived there Sunday and had a full day Monday of meetings, and then Tuesday morning, first thing in the morning, we went down to what's the other city right in the middle? Another city in New Zealand there. Full day of meetings. Wednesday morning, fly over to Sydney, full day of meetings, right? Thursday morning, fly down to Brisbane, I think, or Melbourne. I don't remember. It was 5 days, 5 different cities, 5 different time zones, and then right back into, I think I went to DockerCon at the end of it, or KubeCon or something like that in Austin. So anyways, so happy Wednesday. Thank you, everybody, for joining us. We really appreciate you joining us here for the Ask an OpenShift Admin live stream. So this is one of our office hours series of live streams here on Red Hat Live Streaming. That means that we are here for you, for our audience. Whatever questions you've got, whatever things you want to ask us, we're more than happy to do our best to answer those questions. If we don't know those answers, we'll do our best to find them here while we're on the stream. Usually you'll see one of us, if one of us is running our mouth, the other one is typing away, and we're either responding to chat or asking questions in the background of engineering or product management or whoever it happens to be. So yeah, if you're not watching us live, you're more than welcome to reach out to us as well. So reach out. You can find me on social media at Practical Andrew, on Twitter, on Reddit, on all of the things. Or you can reach out via email, very simply, andrew.sullivan@redhat.com. Johnny also available, JONNY@redhat.com, or JRockTX1 on all the social medias.
Right.
So I really need to like pre-stage this and have it ready. But we also have a couple of communities that I would suggest people get involved in. Of course, Reddit and Twitter and all of that. But the Kubernetes Slack team has an OpenShift users channel as well. So that's a great one. Like Johnny and I are both there, along with a whole bunch of other folks. It's a great place to go and interact with Red Hatters, interact with other community members, ask questions, answer questions, that type of stuff. What are we talking about today, Johnny?
Resource optimization. So the scheduler and descheduler.
Right. Yeah. So this stream came about because I was answering some questions with some internal folks about more or less how do I constantly balance, how do I rebalance, how do I manage the resources that are being used by my pods. So if we think about it in terms of virtualization, we would think things like DRS, right? VMware's dynamic resource scheduling, or Rev has the same thing, and where it tries to balance the resources out across the cluster, and it will, constantly every minute or 5 minutes or whatever it is, it evaluates the resource utilization of the nodes, and it'll take action in order to do that. So more or less, the question was, can we do that with OpenShift? And it's not even really an OpenShift question; it's a Kubernetes question, right? Can we do that with Kubernetes? And I sort of, off the top of my head, replied with, well, maybe, right? So through some things like eviction, through the descheduler, as well as through things like secondary schedulers and scheduler profiles. So this stream is sort of I'm not going to say it's a proof of concept, but rather it's let's look at these things together. And as we sort of explore them, do we think that this is a valid option? So it's kind of spoiler alert. We do have a demo or a couple of demos set up here. We don't have anything, at least I don't think we stage anything, Johnny, where we put all of them together and test it out. So I don't think we can look at it end to end yet. And that's mostly because independently, they are all very interesting. And we should be able to just predict what it's going to behave like. We'll talk more about that in a few minutes. So before we get started, let's talk some top of mind topics. Let's see, let me check our notes document here. I'm back on a laptop again, so I'm juggling multiple windows on one screen, which is unusual for me. So I have this terrible camera, which allows people to see how much I gesticulate, by the way. Normally people only see from like here up, and so hopefully that's not distracting to anyone. Let's see, I need to turn this on so that way y'all can see my window, and then switch over to here. So the first thing that I wanted to bring up, so I thought this was a pretty big one, especially for anyone who is doing, a lot of folks are doing .NET applications, whether it's on Linux or whether it's on Windows itself. Windows nodes and OpenShift, Windows containers and OpenShift are a thing. There's a number of customers who are using that in production. But I thought this was really interesting. So the .NET SDK, basically they added container support directly into their CLI. So by doing a .NET publish of your application, it'll go out and build a container for you. So you can see just very quickly in the TLDR here at the top, here's my application. I'm going to publish it using .NET Publish. It's going to, here we see operating system is Linux. It builds the container, and then I can do a simple, Docker podman run. I can put it into Kubernetes. I can do whatever it is that I need to do inside of there. So this one to me is really big. It dramatically simplifies the process of, creating Windows containers for any of those application folks. So I don't know whether or not, whether or not any of you who are listening to us or watching us, if you have any .NET applications, I would definitely point this out to your developer teams if they don't already know about it. I'm gonna try and keep an eye on chat here. Different windows, so I might be a little slow. Let's see what was next. We got, so we had a couple of folks reach out. I'm gonna turn off my screen share here. So we had a couple of folks reach out with emails, various topics that Johnny and I responded back to, and I wanted to very quickly recap those questions and sort of the answers. So the first one is around disaster recovery with OpenShift. The person was asking, a pretty straightforward question, which is, hey, what's the supported method for doing disaster recovery with OpenShift? Because when you look at all of the blog posts and all of the other things that are out there, the closest thing that we call disaster recovery is, ODF with ACM and OpenShift, which we talked about way back when with the nets. Do you remember what episode that was, Johnny? I hope I'm not talking to myself. Johnny, you look frozen. I heard you say no, but your video is frozen.
Yeah, my video is all jacked up right now, so I'm actually gonna drop and come back in.
Okay, well, I'll keep talking while you're gone then.
Yeah, and I'll find the video for Annette as well.
Okay. Yeah, so way back when, it was probably 6 months ago, we talked with Annette. She showed, at the time, the upstream project, or I guess it's still the upstream project, but what was not even available downstream, tech preview, dev preview, anything, for using a project called Ramen to do cloud native, or Kubernetes native configuration of replication for ODF, for Rook with Ceph. So that has evolved, and it is now available in tech preview, I believe, as I don't think we call it OpenShift disaster recovery, but it's like ACM with disaster recovery, or OpenShift data foundation with disaster recovery, something like that. But it's effectively exactly that, right? I have two clusters. I have ACM. I have ODF configured in each one of those. So in one of those clusters, I configure the disaster recovery, and it's basically syncs all of the application metadata up to ACM, so that way ACM can deploy those things, and it coordinates with the other ODF to replicate any persistent data that's inside of there. So we can use that to do disaster recovery of applications. It's just not tech preview, or it's not generally available yet. It's still tech preview. So what is generally available? What is supported? Unfortunately, there is no end-to-end solution that's available. The way that I tend to break this out is, and we've done a couple of streams, we'll dig up the links and we'll share those. We've done a couple of streams on disaster recovery with OpenShift before, and we have to decouple the applications from the cluster. And I think even further, we decouple persistent data from the cluster as well. So usually the way that I talk about this, especially for folks who have done like virtualization before, is, let's say I'm running a Red Hat virtualization cluster, or a vSphere cluster, something like that. If disaster strikes, I can't, the power fails, or the network gets cut or something like that. I can't just go in and pull those servers out and move them to a new data center, put them in the rack and turn them on and expect everything to just come back. So OpenShift is the same way. If I have an OpenShift cluster at my source site, my primary site, and disaster strikes, I can't just move those VMs and turn them back on at the disaster recovery site and expect the applications inside of OpenShift to come back. So the pods might try and restart, but is the persistent data there? Are all of the service names the same, right? There's just a ton of stuff that happens inside of there that needs to be validated and ensure that it really does come back. And that's just the applications, never mind the OpenShift cluster itself. OpenShift doesn't tolerate things like DNS names changing or IP addresses changing for the control plane. So the short version is effectively there is a supported way of doing it, but it is not a sort of cohesive or end-to-end solution. Instead, it's a combination of a couple of different things. So maybe I use ACM to deploy a new cluster or maintain a cluster at the recovery site. That way I have two clusters. I can manage their configuration using the same policies, the same set of stuff inside of ACM. I can do the same thing with GitOps, right? I have two clusters without ACM, but I use GitOps to manage that configuration and keep them running equivalently. From the application perspective, we want to take a similar type of approach. Welcome back, Johnny. So from an application perspective, how do I recover? How do I restore the things that application needs? So, of course, that's things like the pods, the service definitions, routes, secrets, config maps, all of that other stuff. Maybe I use ACM. Maybe I use GitOps. Maybe I use a simple bash script that goes through and redeploys everything. Kind of any or either or something, anything similar to that will work in that respect. And then the data portion, or the persistent data stored in persistent volumes, that was hard to get out. For better or for worse, we tend to, I'll say, kick the can, or we offload or shirk responsibility, I guess, for that over to whatever the storage provider is. So if you're using ODF, for example, OpenShift relies on ODF to do the data protection piece, however that's done. If you're using Dell EMC, we rely on whatever's underneath the covers there to do it, or NetApp, or Fujitsu, or Hitachi, or Pure, or Portworx, or whatever that happens to be, we rely on those. So, within Portworx/Pure, they have like PX backup. I can take a volume and I can back it up to something else. Generically, we have things like Valero, which can take the contents of that PVC and back it up into an S3 bucket or S3 compatible storage. And then I can restore it into a new PV. So it's very much not just a point and click thing today. Rather, it's I have to recover the PVC, I have to recover the application, right? And then I can begin doing those things. The good news is it's getting better. So in the future, we'll have things like OADP, OpenShift APIs for data protection. And we're working with a number of partners as well in order to make that just easier. So OADP makes it easy to get all of those things that are relevant to an application in a much easier method. Basically, from a third party, from a partner perspective, they use OADP to say, I want to back up this application, and they don't have to know or care about any of the OpenShifty things. Instead, they just get it all from OADP. I'll pause there. I know you're back, Johnny, so I don't know if you are still troubleshooting or if you got anything to add.
No, I think you got it covered. The OADP stuff is super awesome, and I mean, as it's like maturing and getting better and better, I think that it's just going to be fun to use, and I think that it's going to solve a lot of problems.
Yep. So what was the other one that we had? The other one was much shorter. I know I spent like 5 minutes walking through that description. Other thing that we had here. Somebody sent an email asking about how to size the hub cluster for OpenShift Platform Plus. Basically, is there a sizing guide for that cluster? So just to kind of flesh out or explain some of the acronyms or some of the components here. So OpenShift Platform Plus is a combination of 5 things: OpenShift Platform Plus, ACM, ACS, Quay or Key, depending on where in the world you are and which English you speak. And what am I missing, Johnny?
It's got ACM, ACS, Quay, ODF.
ODF, yes, thank you. Yep. ODF Essentials. So it has those 5 things inside of that bundle. And one of the patterns we've seen is folks will create effectively a hub cluster. So it's an OpenShift deployment that is all infrastructure nodes, because every part of those is infrastructure workload. And then, so you don't have to entitle it, but then you deploy all of the controllers and all of the other centralized parts into that hub cluster. So the question was, how do I size that? how do I know how big my, ACM instance needs to be based, if I don't know exactly what the number of clusters or the type of clusters or anything like that. Unfortunately, there is no easy way to do that. I wish there was. I dug around, I asked around, and the response basically every time was go look at the sizing guides for the individual components, add them together, and make a best guess effort based off of that. So I wish we had something better than that, but we'll figure it out. Johnny, I know your team has done a little bit with sizing stuff. I don't know if you had anything there.
Well, I mean, so we generally will size based off of like like the medical diagnosis pattern. So we'll start with like a m5.xl machine type from AWS, right? And then kind of like, okay, ODF will not deploy on this if we keep it as a compute node. So what we try and do is we try and say, okay, if I'm gonna like essentially co-locate multiple services on multiple compute nodes, like what's it gonna take to make this thing run before I have to start actually like separating out the nodes. So we do have some like, it's like really rough sketch. Hey, if you want to run ODF and you want to run OpenShift serverless and you want to do some of these other things, you're going to have to go big on your computes, or you're going to have to separate out your infra and storage nodes, and then you can just kind of manipulate some. But an M5.4XL fits OpenShift data foundations, and then OpenShift serverless, as well as Grafana dashboards and some other stuff. So I mean, but that's a lot of resource, right? And that's that's a big AWS bill at the end of the day.
Yeah, such as the price of progress, I guess.
Yeah, indeed. That's what we want to say. Yeah.
All right. Well, I think that was. Did you have? Unless you had anything else for top of mind, that was all I had.
No, there's a lot of stuff. Keep an eye on the Kubernetes blog and the Kubernetes website, especially with all the changes that are coming out in 1.25, which is going to be in OpenShift 4.12, because there's a lot of things that are coming. There's a lot of capabilities that are coming out that are going to be pretty awesome. There's going to be the C Group V2, and then there's going to be other aspects of just the Kubernetes framework in general that's going to come out and be beneficial to everybody. But there's also going to be things that we're changing, like the pod security policy going to pod security admission. So just keep an eye on that, so that way you're aware and in the loop, and you don't get caught off guard about what's going to be released in OpenShift 4.12, but then Kubernetes 1.25.
Yeah, we should probably do a deep dive on the whole changes with pod security policies, pod security admission, SCCs, all of that stuff inside of OpenShift, and not just on where it's at, but where it's going and what it's going to look like. Sort of like we did that. I think I said, I was giving you kudos for hosting, for emceeing the internal enablement on that. Probably something like that, just here on the stream.
Yeah, that's a good idea. Especially like you can kind of see it now if you're running OpenShift 4.11. You can see where the SCC v2 or the restricted v2 SCC is in play. That's just the beginning. So I definitely think a deep dive on that would be a good idea.
Yeah, and I'll probably make any of our security folks cringe with my oversimplification, but it's one of those like, SCCs existed in OpenShift because there was nothing at the native Kubernetes level to do that type of functionality, and now that's being added. So it's not that it's creating a conflict, but it just means that things are changing. Especially for OpenShift, longtime OpenShift users, and how they've managed those the RBAC and stuff like that. Yeah,
totally agree, and I think that it's that migration or that evolution to the security, the DevSecOps, right? Where, it's baked in, it's part of the ingredients instead of, like a topping or, some extra thing. It's actually, it's part of the base, which it needs to be. And so it's a good thing. Good change. It's just, with change comes some difficulty sometimes.
I don't know what you're talking about.
Yeah, right.
Change is easy. Everybody loves change.
Exactly.
I did think of one other thing that I wanted to say in here. Let's see if I can find it without creating long, awkward pauses.
I can sing if you'd like.
That would just be a long, awkward non-pause. I don't know. I got nothing. So I wanted to quickly highlight to folks that I've said this a couple of times. We've got a bunch of stuff planned. So in the near future, we'll be talking about composable OpenShift. I talked with that team yesterday. We just need to nail down the date with them. We'll be talking about hosted control planes, the artist formerly known as Hypershift. We'll be doing an OpenShift for Kubernetes admins on kind of a 101, 201 type of thing. So if you're mostly or only familiar with Kubernetes, what's the difference between, quote unquote, vanilla Kubernetes and OpenShift and the things that we can take care of there. And I think we're also going to try and plan some OpenShift Platform Plus stuff, just a whole bunch of stuff. And that's not even, I think there's a couple of others that I'm missing here because I haven't updated this list that is like way back in our chat, Johnny.
Mm-hmm.
So for anybody who is curious to any of those topics, as well as whatever else we've got going on, please don't hesitate to subscribe on whatever platform you're on, so that way you can get alerts when we go live. I'll also encourage you, I always encourage folks to go to the Red Hat live streaming landing page. So let's see, where's mine? So if I switch back over to this guy, if I go to red.ht/livestream, oops, I spelled streaming correctly, red.ht/livestream, you land at this page. So if you look at this page and you switch over to this episode calendar, this has all of the streams that we have coming up. And you can also click this little link down here in the corner, and that will add it to your calendar as well. You can turn it on and off in Google Calendar and all that other stuff if you don't want all the noise. But yeah, it's a great way to keep up with what we're doing and all that other stuff, as well as social media and everything else.
Yeah, and if there's a topic that you want us to talk about, like if there's something within OpenShift or Kubernetes or whatever that you're like, man, it would be awesome if they would just talk about this, hit us up, let us know, because we will definitely try and get the nerds that do this stuff every day. We'll try and get them on and have them come and do a demo and talk about it. That way you can ask your questions.
Yeah, absolutely. Johnny and I we're pretty good at coming up with ideas, but we also we would much prefer to address things that we know that you all, that our audience is interested in. So don't hesitate to reach out and say, hey, would you be willing to cover this, or I think this would be a great topic, or that type of stuff. And that includes for any Red Hatters that are watching, not just folks who are our customers. Any Red Hat field folks, any Red Hat product managers. We love to have you all. All right, let's talk about today's topic, Johnny.
Let's do it.
All right. So as I said before, we wanted to talk about how to manage resources inside of a cluster. And in particular, how does the cluster do things like manage resource contention? How does it try and balance resources? What happens if there's one node that is really, highly utilized and another node that is underutilized? How can we help to maybe bring those closer together? And there's a number of reasons for doing that, and not at the same time. Johnny, I was a VMware admin for a long time. I was a Rev admin for a long time. With virtualization, it was usually about failure domains. Mm-hmm. Like, yes, balancing resources, making sure that there is no contention and stuff like that is important. But for me, it was, I don't want to have an imbalance of virtual machines on one node, so that if that one node fails, it creates a bigger ripple than necessary, if you will. So the same might be true for your Kubernetes applications, or it might not. I'll say that Kubernetes applications are oftentimes different than what we find in virtual machines, right? Virtual machines, they know, they trust, and they rely upon the infrastructure to provide things like high availability and all of that. Cloud native applications, things that are typically deployed into Kubernetes, they are often, because they're container based, they expect things to fail all of the time. Containers don't live migrate. Containers stop and start, or terminate and instantiate. That's the word I was looking for. So a lot of times those applications are just better at handling when those types of things happen. Usually, right? It also means that the application has to be architected for that. If I have a single instance of a pod, that's a single point of failure. If that pod goes down, something is broken. So horizontal scalability and all of that stuff is important, assuming the application can do it. So I think with that in mind, we wanted to take a look at 3 features of Kubernetes that play an important role here. So I'll be looking at eviction and hopefully the Descheduler. I say hopefully because I tried it once yesterday and I think it worked, but I don't know for sure. So we'll learn together. It'll be fun. And then Johnny, I think you were going to look at the secondary scheduler.
Yeah, and it'll be similar. Like we'll get the operator deployed. We can see the deployment going, it doing its thing. But there's been some upgrades to the API version, and so I think that's causing an issue with the scraping of Prometheus. So I actually reached out to the engineers right before this to, essentially double check my work. But we'll walk through all of that, and then whenever we do publish the blog for this episode, I'll have all the right stuff in there.
Awesome. Yeah, and I've got a markdown page over here, a gist. So I'll share that gist along with any edits that we need to make after this particular stream. All right, so what was I looking for here? I was looking for, here we go, eviction. So eviction has two different ways that it works. So if we look in the documentation here, you see we have eviction hard. Oh, come on. We have eviction hard, which is configured and there by default, and will take immediate action to rectify the situation being a resource, an exhausted resource condition. And then we have soft eviction, or eviction-soft. So this is not configured by default in OpenShift, at least in the OpenShift 4.11 clusters that I've deployed. So effectively what this is it's a lower threshold that when it notices, so let's say that, and actually I can show it here. Oh, my browser's going so slow. So over here, I've got, the soft eviction configured so that when memory available goes below 4 gigabytes, it will basically request in the normal way that the pod terminate, and then it'll reschedule it, through the Kubernetes scheduler. Whereas the hard eviction down here, which this configuration sets it to 1 gigabyte. So if the node has less than 1 gigabyte of memory available, basically it goes in and it says, I'm going to begin terminating immediately, without hesitation, without kindly asking you to terminate. I'm going to terminate this pod, basically to free up those resources. So this configuration, which we'll look at in just a moment, I've applied this against my test cluster. So that way we can show a couple of different things with that. You'll also notice that we have a grace period for the soft eviction. So it will give it up to 1.5 minutes here in order for that pod to terminate. If it doesn't terminate within that period of time gracefully, then it will do a hard terminate of that application. So if we flip back over to the documentation here, I've only configured it on memory, but you can also configure it for disk. So you can see the amount of capacity available on the node file system. So this is going to be, I think, specifically /var, if I remember correctly, as well as inodes, and then the same thing for the image file system, which is going to be varlib containers, if I remember correctly. So these are important because remember, when I instantiate a container, it creates that copy on write layer on top. So anything that isn't stored in a PV goes to that copy on write layer. Same thing with empty dirs, right? All of those things, they all get created underneath these file systems. So this gives the node the ability to figure out like, hey, I could be running out of storage, or I could be running out of inodes. I need to start terminating pods so that those copy on write layers can be removed and I can free up file system space. So that's where that comes in. And there is, as I'm sitting here talking about this, there is a KCS that talks about how if you mount, because it's technically possible for you to create additional disks or have a second and third drive attached to your OpenShift nodes and mount those as /var or /varlib containers. It can affect how it does the monitoring for this. So again, when we finish up the stream here, we'll add in that. I'll add in that to this gist, and I'll share the gist on social media and all that other stuff as well for anybody who's watching. As well as we'll put a link to it in like the YouTube video description and all of that, so that way it's easy to find. But I'll include links to that KCS so that way you're aware of any impacts to doing that. From what I recall, it's just if they're nested, it affects how it detects memory or a file system utilization at one level or the other. Anyways. All right, so kind of as we scroll down through the documentation page here, right, you can see a bunch of different stuff around like cleaning up images that are on the node. So this is specific to storage, right? As over time, so say I've got an application, a pod that's deployed to the node, and every day the dev team, the app team is releasing a new container image. And each one of those is, 500 megabytes or a gigabyte in size. Over time, that can cause my file system to fill up. So like image garbage collection is how often it looks and how much it cleans up the file system by removing unused container images. So down here in the docs is where we have this, this kubelet config that walks through how to configure all of these things. So let's switch over here. So if I do an OC get, come on browser, you can do it. You're not going to do it because it's disconnected. Hopefully this will work. There we go. OC get kubelet config. And of course not. Got to export my kube config again.
I probably hit this like 10 times a day. This gives me almost every single time.
Yeah, I know, constantly switching, and this is so I'm in the office, right? I'm in the tower, but you notice I'm still on my normal, Bastion work server because I'm VPN'd into my house, so that way I can, connect to my normal set of resources and have a familiar, somewhat familiar, right?
Yeah.
Environment. So I think when I connected to the VPN, it blipped everything and didn't work. Anyway, so OC get kubelet config. So I've got this worker kubelet config. If I do -o YAML, I think because there's only one, it'll just spit out the one. And we can see here in the spec, right, exactly what I was just showing in the gist over here a moment ago. So the hard eviction is set to 1 gigabyte. The soft eviction is set to 4 gigabytes. It gives it a minute and a half of grace for the pods to terminate. And then this pressure transition period set to 0 seconds. So basically what that means is, let's say that I've exceeded this or have less than 4 gigabytes of memory available, so it requests a pod to terminate. The pod terminates. Now it has more than 4 gigabytes. It doesn't wait any additional time to transition the node out of the memory pressure type of situation. All right, so let's do our OC get node. And in this cluster, I've got, you can see 1, 2, 3 control plane nodes and 1, 2, 3 compute nodes. So if I do a describe on one of these, if I do a describe on one of these, there's a couple of interesting things that we want to look at. So normally, when we talk about resources, a lot of folks experience frustration because what they'll see is the actual utilization of the node is pretty low, but the scheduler won't schedule things to it because of the requests, right? Requests are tantamount to a reservation. So usually we look at this allocated resources section to see, oh, well, how much of my resources, 18 and 21% respectively, are tied up with, basically requests for the applications that are there, even if it's not actually using it. But for the purposes of this, what we care about up here are the capacity and the allocatable section. So capacity is going to be kind of the full size of the node. So if you look at this node here from memory, it's 16129,396, right? So basically 16 gigabytes, just expressed in kilobytes, of memory assigned to this node. I don't remember what type of machine this is in AWS, but it has 4 CPUs and 16 gigs of memory. But you'll notice down here that we've got allocatable 3.5 CPUs and 14 gigabytes of memory. So why is there a difference there? Effectively, it's system reserved resources. So it automatically or by default it reserves half of a CPU for things like kubelet and the other low-level system level things to have resources available. Same thing with memory. So this 14 gigabytes is the real amount of memory that we can allocate to pods that are running on the system. And as we scroll down, we can see down here that 2.8-ish gigabytes has been tied up inside of requests. Make sure I get the right node here. So I can do an OC-ADM top node and then give it this node name. And we can see real resource utilization is 6% for CPU and 25% for memory. So scrolling back up here again, you can see that even though the requests have 18% of CPU and 21% of memory tied up, basically again in reservations, real utilization is below that. Okay, so that's node resource utilization in a nutshell, right? So what happens if a node comes under pressure? So first, if we look up here underneath conditions, you'll see we have memory pressure, disk pressure, PID pressure, right? And where it's basically declaring whether or not it is experiencing memory pressure would obviously be, am I running out of memory? And right now it has sufficient memory, so it's not complaining. Same thing with disk, etc. So let's cause a problem, if you will. So after some random internet searching, I stumbled across a person on the internet, and I'll bring up the blog post here. So this is a really interesting series of blog posts that they created. You can see it's from earlier this year. But what I have effectively plagiarized is the pod that they use in their demo here. So the pod that they've created basically does a memory allocation activity. So let me move back to my gist here. Come on. So when we look at our gist, right, we see that it's just using allocate memory. The -x is going to be, what is the maximum amount of memory that it will do? What are the increments that it does it in? And then how quickly it will allocate that out, as well as spit out some statistics. So what I want to do is basically create this pod. And a couple of things to note here. So first, I need to create a new project. New project. Oh, I guess it helps if I'm using the right window. I'm doing it in my terminal window, which you all can't see. OC new dash project. I can't type and talk at the same time. It's just not possible. All right, so I just created this alloc, ALLOC project. So I want to create one of these pods inside of here. So I'll do a cat here doc and pipe to OC apply -f. So the dash there indicates it should accept from standard in. We will paste. Into here and allow it to create our pod. Okay, so do an OC get pod. So we can see it's in the container creating status, and if I do -o wide, it was assigned to this 195.54 node, and it is already running. So I can do an OC logs on my pod here, and you can see that it's going through and it's consuming memory, right? So it's adding 100 megabytes of memory each time, right? It's slowly increasing the memory that it's using over time. So this can mimic a number of different things, right? An application with a memory leak, it could mimic an application that just is constantly doing things and constantly consuming more and more memory, all that type of stuff. We can do that again, see what's happening. But let's look at our node. If we look at our node now, you'll see a couple of things. One, our requests and limits haven't changed, right? They're still going to be low here. But as I go up here and start looking, our memory is going to start coming under pressure. Do that OC-ADM top node again. We see ADM top node. Or this guy. So if we look at the memory here, you can see it's at 60% already. And if I keep watching this, it should be continually going up. It should be going up. Yeah, so it's at 8,800 now, 9,400. Let's look at our top node. There it goes. You can see our memory's at 71%. So remember, I set the soft eviction threshold at 4 gigabytes, which is 75%. So what we should see shortly is our node go into a unhappy status. And what we're going to see is some events start happening. We can come over here to compute and nodes. Basically, things are going to get unhappy, and it's going to start telling us about it. Cluster am I on? Why is that? Oh, I'm on your cluster. That's why. All right, I'll fix that in a minute. All right, there we go. So you see what happened here, right? It went from 82% and then it reset back to 9%. If I do an OC get pod, you can see that my container is now unknown. Do an OC describe pod. And so here we can see the node was low on resource memory and the pod was using too much. So now it's stopping the pod. So, and we can see over here, the reason is the very polite killing.
Mm-hmm.
So basically, and if I do an OC, so effectively what we've seen is a soft eviction that just happened. So can we cause a hard eviction to happen? So the difference with a hard eviction is with the soft, right? It said, hey, you know, it was a standard kill, was it kill -3, kill -5, as opposed to a kill -9 operation at the CLI for the process. So I could cause a hard termination here. You can tell that I tested this before I put the other soft eviction threshold in. So we can cause or force a hard allocation by changing this guy. And apologies, I'm going to do this off screen.
And Andrew, there's a request to share the link to that blog that you found for the pod that consumes a lot of memory.
Yeah, I'll do that in just a minute. All right, so let's try this again. So OC get pod, OC delete pod, allocate hard. And now we'll do our same cat here doc. And we'll do our OC apply. So the change that I've made here is it now increments in much larger chunks. So what we should see happen here is it will reach this 15 gigabytes of utilization within basically less than 8 seconds. So that should, it may trigger it, I think. It may trigger the, it may consume memory faster than the soft eviction can trigger it to remediate itself. I guess we could force the issue by making it even faster just to see what happens, right? It's the worst that happens. I break the cluster. We'll bump that up to 4 gigabytes at a time.
Do it.
All right, so OC get pod. So it's container creating. We'll do that a bit over wide. See what node it's on. So it's running. So there it's got a couple of iterations. You can see it did a restart. So the restart is it got terminated the first time and then it restarts it to see if it'll behave properly. And what we should see is after a few seconds, Yeah, there we go. It reaches that out of memory killed status. So that's what a hard termination looks like, or a hard eviction looks like. In theory, that the pod would get rescheduled again after some period of time and hopefully land on a different node. But I'll point out that I get asked sometimes, like with OpenShift virtualization, can I do memory overcommitment for a virtual machine running in OpenShift in Kubernetes or virtual machines? And the reason why you can't do that is for exactly this. Kubernetes, OpenShift, or OpenShift, but also Kubernetes in general, has no mechanism for overcommitting memory. So there is no swap, right? Remember, we turn off swap.
Mm-hmm.
There is no ballooning with OpenShift virtualization. There is no key same page merging or anything like that. So if your node comes under memory pressure, it's going to terminate those pods, including virtual machines, without hesitation. So it's the same thing as a hard crash for a virtual machine. So if anybody's ever curious, that's why. And that's why they also, the OpenShift virtualization team will also create a request or reservation for the full amount of memory for the virtual machine to prevent that type of scenario from happening. All right, quickly, just in the interest of time. So first, let me grab that link from here. And Johnny, so I can plow ahead, I'm going to
go for
share this on our chat, and then I'll ask that you post that.
Yep, all over.
So the other thing that I wanted to show real quick is the Descheduler. So the Descheduler is an interesting one in that it does exactly what it sounds like. It deschedules, it removes pods from nodes that have certain conditions being met. So come on, switch tabs. I go to the Descheduler documentation, right? So evicting pods using the Descheduler. Effectively, once we configure the Descheduler, we also configure the policy that we want it to use. So you can read through all of these, right? Affinity and taints is basically if anti-affinity or taint conditions aren't being met, it ejects those, right? It evicts those pods. If it's not meeting topology requirements, or if there is, here it ensures that there's only one pod associated with replica sets or job running on the same node, right? So lifecycle and utilization is the one that I think most folks probably think about when they think about balancing resources. And that's because we have this low node utilization policy here. So low node utilization will look, and by default, it looks to see if any nodes are below 20% utilization for CPU memory and number of pods. And it looks to see if any nodes are above 50% utilization for any of those thresholds, CPU memory and number of pods. So what should happen here is if my node is above 50% utilization, but below our normal eviction threshold, soft or hard eviction, it will say, hey, these pods are eligible for eviction. If I also have nodes that are below 20%, then effectively it will evict those eligible pods from down here. So there's a very important thing to be aware of here. If you don't have any nodes that are below 20% utilization, it won't do anything. It very distinctly looks for that below utilization, that low utilization threshold. So even if you have a node that's 80% or 90% utilized and your eviction thresholds are set appropriately, and one that's 21% utilized, the descheduler won't take action there. So you can adjust that. So if we scroll down here, so we've got this, it says dev, and it is experimental, but you can adjust it by setting one of these low, medium, high, and it will take appropriate action. I don't know if you can adjust these numbers more than that. So I don't know if you could have like 70% overutilized and 10% underutilized in the same policy. Rather, it's these t-shirt sizing.
Mm-hmm.
So just real quickly, because I'm running out of time, deploying the operator is pretty straightforward. We just follow the directions over here. follow the directions over here. I will say that I probably won't demo this again in the interest of time, because I want to give you adequate time to demo the secondary scheduler. And also my laptop is now popping up an error message because apparently the plug that I'm plugged into is not plugged into the wall. Yes, now that I look, it's zip tied to the underside of my desk here. So I've only got a few minutes, about 20 minutes before my laptop dies. So that's slightly terrifying.
Always awesome.
Yeah, never a dull moment. Where did my thing go here? Yeah, so I will not actually deploy this then. It is in the gist that I have over here. So again, after the stream, Johnny and I will combine the notes that we have into a single gist. I'll make any updates that we need to do inside of here. And then we'll share that out through all the normal mechanisms and all that. So keep an eye out, especially in the description for the videos on YouTube. We'll make sure to put it in there. Anyways, so Descheduler, the main thing I wanted to communicate there is, again, about that low node, or excuse me, where'd it go? Lifecycle and utilization. This low node utilization takes into account, or won't take action if nodes aren't below this threshold. I'll also point out, right now, you can't decouple these policies from each other. So if you use lifecycle and utilization, you get all three of these put together. So pods having too many restarts, that's kind of a take it or leave it, right? Maybe it's good, maybe it's bad. But this pod lifetime might be an issue for some folks. So effectively what it's saying is that any pod that is older than 24 hours is just automatically kicked and rescheduled. So that could be good. I have an application that has a known memory leak or something like that, or it has whatever, maybe for whatever reason, I want to have it restarted after a period of time. It does take into account things like pod disruption budget and all that other stuff. But a lot of people might not like that. So there is no way to do this without pod lifetime today. So the OpenShift virtualization folks, let me see if their documentation is in here. So they have I don't even know where it would be inside of here. So they have a dev preview of a lifecycle and utilization policy. I think they call it like long lifecycle and utilization or something like that. That omits this pod lifetime. It is dev preview. I don't know. I've asked product management, but I haven't gotten a response yet. I don't know whether or not we'll be bringing that to all of OpenShift, or if it will be tied specifically to OpenShift virtualization. But just be aware of that if you do decide to adopt this, that it will restart pods, all pods, any pod that is older than 24 hours. But yeah, other than that, it's very straightforward. You can limit it, and it walks through in the documentation here. You can limit it to taking action on specific namespaces as well. So I would say, and I would encourage you to do that, although by default it will exclude any of the OpenShift and OpenShift -star and kube -star namespaces. So you don't have to worry about it affecting core system stuff. But yeah, again, over here in the Markdown, which is substituting for our blog post, I have an example of how to trigger a deschedule, so you can see that in action, so you can kind of test it or experiment with it before maybe implementing it in production, because we don't ever want to test in production, right? Allegedly. Yeah, that never happens. All right, I'm going to stop sharing. I'm going to hand you the keys to the kingdom and secondary scheduler.
Okay, awesome. So let me see if I can actually do this. Let's see. Okay, so the secondary scheduler is, it's well, essentially the default scheduler uses things like filters, and there's another thing that it uses to schedule a pod to a node. I can't remember what it is, but it's filters and something else. And sometimes when you have an application that's maybe like an HPC app, or maybe you're a telco customer or something like that, and you have to have very specific requirements, and the default scheduler just doesn't do it for you. So there's this thing called a secondary scheduler that's been implemented, and the cool part about it is that there's really 3 different types, and there's this. I'm jumping around, and I apologize. There's a blog that was written by some folks at Red Hat that kind of go over the secondary scheduler implementation, and the 3 different types of schedulers that you can use are like co-scheduling, which is where you can start and stop the pods all at once. And when I was digging into this one, this is really more like, this to me seems like the telco type or edge type of customer would be using this, where I have very limited capacity at the edge or at that environment, and so maybe I only want 3 of those pods, maybe 3 Nginx pods running at the edge. And so then I can say, hey, I want my minimum number of pods to be running as 3, and then essentially my replica set will bomb out and have them set as pending. So if I have like 6 in my replica set, I'll have 3 running, and then the other 3 would be pending. And so this is kind of cool because you can spin everything up together, and then you can control the number of pods that actually get deployed. The other one is the topology aware scheduler. So this is when you have like NUMA nodes, and you really want these nodes to be similar in configuration. And then what it will do is it will schedule nodes based off of that topology. It becomes topology aware. And then the last one is the load aware scheduler. And then it's just how it sounds, right? It's taking in capacity. It's using metrics to determine if the node is overwhelmed or underwhelmed, and then it starts scheduling based off of that. And that's the example that we're going to use just straight out of this blog. Just keep in mind, though, that the API has changed since this blog. So I'm able to deploy the operator, and I'm able to get the deployment running. But the way that the application or the operator itself interacts with Prometheus is messed up. So I've got an email out to the group that wrote this. So as soon as I get that feedback back, we'll put that into that gist. And then one last thing before I start in on the demo is you can actually write your own scheduler. So if you have, maybe you're using like real time. I'm not 100% sure if real time is supported just yet, but if it is, and you wanted to write a scheduler that can support real time, there's a framework that you can actually go and use to write your own scheduler that you can use for that real-time application. So there's a lot of flexibility here. There's a lot of capability. And to be honest, like the more I was digging into it, the more I was like, oh man, this is really awesome. But yeah, just know that this stuff is out there. So just jumping over to the OpenShift console, you install it just like any other operator. So go to Operator Hub, and don't listen to ignore my dog. They're upset because somebody's outside. So it's the secondary scheduler operator.
Been there, done that, Johnny.
Yeah, he's the little dog, so he's actually the one that barks the most. The Roddy doesn't do anything. But I need to create a namespace really quick, and it's just going to be called the. I'm going to have to do this from my shell that you can't see, so it's going to be kind of weird because I have to create a namespace and not a project, because I'm going to name it OpenShift-secondary scheduler. So if you're trying to create a project with OpenShift in it, the API will block it. Let me just open this up really quick.
Yeah, and you have to create an OpenShift dash anything namespace as a cluster admin, and you have to do it. You can't do it from the GUI. You have to go into the admin panel and then go down to new namespace. You can do it that way.
Wait, so you're saying?
So go all the way down to the bottom, the admin panel.
Oh,
yep.
Dude, yeah, you're right.
And namespaces.
I forgot about this.
I got my laptop plugged in, although magically when I plugged it in, the battery dropped from 13% to 5%. So
nice. Well, I'll try to make this quick. But yeah, so this OpenShift secondary scheduler, this is the namespace that I just created from the shell. I don't use the GUI that often, so like I should know how to use this thing better. But thanks, Andrew. So next, let's go back over to our installed operators, or Open Operator Lifecycle Manager, and then now we'll type scheduler, and we're going to click on the secondary scheduler operator for Red Hat OpenShift, and we're going to put it in the namespace that we created. So the OpenShift secondary scheduler operator. And so as this is installing, I'm going to actually jump back over to Restream, and I'm going to share my terminal really quick too. I need to do what you've done, Andrew. I need to set up, just whatever it's called, so I can have my shell in the web.
Yeah. Yeah, it's let me find the link for that. Web SSH 2.
So the first thing that we need to do is we need to export a couple of variables because we're going to create a config map. So let me just make dir demo. Right, and then I'm just going to export the Prometheus host. So we're just going out and getting the route. And I see what I did. Oops. Okay, there we go. And then next we need to export the Prometheus URL, which is just going to be the same thing. And then we're going to create a config map that's going to incorporate these environment variables. Echo. And I'm assuming that you can see this okay.
I can see it. Looks good to me. But if anybody
Right.
in the audience can't see it, just let us know.
All right, and so now just going to set up some more variables. So we're going out and we're getting the token from the OpenShift monitoring namespace from the service account, and then this is gonna get put into this config map that we're gonna create, and then that's what we'll be using to scrape the credentials or the Prometheus metrics. Now,
Yeah.
if I just
So just kind of real quick. So the reason why the secondary scheduler needs access to the metrics is because it uses those to make decisions.
Exactly. So we can see we have our default request of CPU 2000, M, and so essentially it's using Prometheus to go out and it's saying, are we underutilized? Are we overutilized? Here's the request that we can use. And then it's our target utilization is 70%. So it's very similar to what you were doing, Andrew, with the descheduler. And so it's using all of that to essentially make a decision on where to place the node after, or where to place the pod after that.
Yeah, and to be clear, if a pod is already on a node, this doesn't affect anything. It's only when the pod goes through the scheduling process. So we need something, eviction, the descheduler, to basically trigger a pod to be scheduled again on a node that maybe we want to adjust that resource utilization.
Yep, for sure. So now I'm just going to create the config map. And then if I jump back over, I need to assign a couple of permissions through the RBAC. So let me quickly grab the service account.
By the way, I just realized like 5 minutes ago that our chat interface, or at least my chat interface here in Restream, was not doing anyone's chat except for the host chat. So
yeah, I saw that too. I wasn't sure what that was.
Yeah, I switched over and I was just replying to our Hope 9 directly in Twitch. But apologies for not chatting with folks earlier. I see comments in here from Christian and Jamie and others. So yeah, I wasn't ignoring you on purpose, I promise.
Well, and now I can't find my go. All right, so what we need to do is I'm going to add the cluster monitoring view role to the service account, and then I'm also going to add view. That's cool. I don't know what you're saying to me.
So the first one, cluster monitoring view, is so that it can access all the Prometheus metrics, and then view is so that it can see all the pods in the cluster.
Yep, exactly. And it's saying that the service account's not created, so we'll OpenShift. Secondary scheduler. There we go. Helps if you're in the right place.
Darn RBAC.
I know. There we go. So now I'm going to jump back over to the UI. Maybe. Windows. And we're going to create the actual instance of the secondary scheduler. So if I go and I create secondary scheduler, we can pretty much leave all the defaults. It's going to use the secondary scheduler config that we created. By default, it's going to pull the image from GKR. So it's just an image that they have that's out there that's using the I think it's like Taramine or something like that. Taramine. It's spelled. It's a unique word, but essentially it's just a plugin that we're going to use as a library within OpenShift to spin up to monitor the cluster and then do the load spreading. So I'm just going to click create.
Is that Trimaran, maybe?
Trimaran. That's it. Thank you.
Yeah. And there's a link to that off of that blog post that you had.
Yep, exactly. And I was planning on having
more.
Oh, sorry.
No,
I was planning on having dual monitors up, so I could actually have my notes going at the same time. So I'm going from memory here, which is we know it's never a good thing.
Yeah, welcome to my world. I'm there with you.
All right, so if we go and we look at our deployments, our pods, we'll start seeing as the resources start coming in, like this pod will come up and we'll see a secondary scheduler. And right now, like I was saying, because of the API difference, it's not going to, it doesn't work. So it can't really go out and scrape anything. So as soon as I have the resources back, or as soon as I have the reply back from the team that wrote the blog, then we'll put all that in. And I'll just re-record the video so we can actually see the deployment. We can watch the logs and we can actually watch it distribute things. But yeah, just so you know that's pretty much it as far as making the change or deploying the config. And as soon as I get feedback from those guys, then I will definitely update that and maybe create a new video with the actual working demo since everything's changed and everything's broke.
Yeah. So the blog post that do you still have that up?
Yep.
So the blog post I know talks about several alternative scheduler or secondary schedulers. So one of the things that I wanted to bring up is why the secondary scheduler and why did Red Hat do the secondary scheduler and not have scheduler profiles or even being able to modify the scheduler like we could in OpenShift 3. And the rationale is the secondary scheduler only affects workload. It doesn't affect the core OpenShift services and things like that. So that was the reason, or that is the reason why we have these two separate things, the scheduler and the secondary scheduler, and why we want to use the secondary scheduler for affecting workload and stuff like that. So Trimaran is the load aware scheduler, if I remember correctly.
Yep.
So as of OpenShift 4.9, the default is to use the the low node utilization scheduler profile. So basically it looks at whatever node has the least CPU, memory, pod count utilization, and it assigns there. So it's very, I'll say it's not super smart. Whereas Trimaran's goal is to take into account not just the current utilization, but looking back for, I think it defaults to 5 minutes, if I remember correctly. So it looks back. Yes. Yeah, so it pulls those metrics over a short period of time to look back and see what has your utilization been, right? Are you currently in a lull? Are you currently at a peak? Are you, do we need to make some other kind of decision based off of that? And I believe that that's configurable as well.
Yep, for sure. And there's other types of metrics that we can pull. So we can see we have our Kubernetes metric server, and that's by default. We're using Prometheus within OpenShift, but then there's the signal effects as well. So I mean, I think that the signal effects was the first one that they were supporting, and maybe the Kube metrics, but signal effects was one of the main ones, and Prometheus is like a newer addition to the Trimaran. But if you go within that blog, they actually give you the link to the GitHub repos, and they've got a really nice README with some diagrams of how everything works. And then if you're really interested, you can go and actually dig into the scheduler and how it makes decisions, because I was reading on that and I was like, I knew it was complex, but it's super complex. I was going through that the scheduler framework if you wanted to write your own. And
Oh,
there's just so
nerding
many.
out on it, Johnny. Nerding out.
Yeah, it was. I was just trying. I was like, oh, you go down the rabbit hole, and
Yep.
I was like, holy crap, because you have like pre-filters, then you have filters, and then there's. I wish I could remember the other object. But there's essentially like you have the pre, and then there's the actual one that it's using.
Yeah.
Let's see, filtering and scoring. That's what it is. So you have the pre-score and then the score, and then it starts to do its calculations to make the determination where it's going to go. It's insane how difficult or how complex it actually is.
Yeah, it is, at least for me, it's interesting on an academic level just to understand what the system is doing, but I'm not smart enough to know how to actually make it dance the way that a lot of people do. So
Exactly.
I'll also add that I guess a bit of precaution of like creating your own very custom tuned scheduler can be risky. Because you don't necessarily want to micromanage everything that it's doing. Rather, you want to let the system do what the system does in many cases. I don't say that to discourage anyone, but rather kind of the age old, when you're trying to do performance tuning or something like that, you don't just make changes and assume that it did the right thing. Rather, you want to monitor and have a baseline and then make a change and then monitor afterwards to see whether or not that change was good or bad. So in this instance, you're definitely going to want to utilize, the monitoring that's inside of OpenShift to, let's say you're using, Trimaran to do the load-based scheduling. Is it more evenly, is it making better decisions by whatever your metrics, whatever, things that you choose? Is it making better decisions and kind of validate that after the change? Same thing if you do, create a custom schedule or anything like that. You want to make sure that it's having the results that you expect it to, and not, necessarily detrimental. I used to, I was a storage admin, and we tweak and tune. There's a phrase for that or a term for that when you merge words together. I don't remember what it is. Anyways, you make performance adjustments all the time, but you don't always know if it actually had a benefit, and you have to have that discipline, if you will, to establish the baseline and then monitor afterwards to make sure that you're getting the expected result.
And the cool thing about the secondary scheduler too is that the kube scheduler, the default scheduler, will continue to work on the control plane. But to your point, like it's not for everybody. And it's definitely use it at your own risk kind of thing. And Red Hat goes into some detail in our documentation. There's not a lot of information in our documentation, but there is some detail about like essentially Red Hat will support the operator, right? So the secondary scheduler operator itself, but your secondary scheduler instance that you put in place, that's on you, right? So like I think that there's some help there with the configuration and helping you essentially get the spec right, but the function and features that you're putting into that scheduler, that's going to be on the person writing that scheduler.
Yep. Yeah, our Hope 9 asks if Trimaran can schedule based on actual usage, ignoring requested resources. I think that would just be the default low node utilization, wouldn't it?
Yeah, I think so.
Trying to see if I have the page already up anywhere, but I don't think I do. I was going to look at the verbiage that's used there real quick. So the good news is the product manager that's responsible for this, Gaurav, is going to be joining us to talk about some other things in the not too distant future. I think I sent you that conversation, Johnny. So
yep.
If anybody has any questions about secondary scheduler, about behavior and stuff like that, let us know. I also, because I've been asking some, we'll say challenging questions of the team who's responsible for this, I've now been added to the Slack team that they use. So for example, one of the questions that I asked is, can we do multi-stage scheduling? So let's think about this, right? So let's say that I have, 3 nodes in a cluster. One node is at, or all 3 of them, I guess, are at 50% utilization. And I have, 3 pods that need to be, or 4 pods that need to be scheduled. And, 2 of those pods consume 20% of resources, and 2 of those pods consume 40% of resources. So what happens if I schedule, the 2 20% utilization pods first? with no low node utilization, one of those is going to go to node 1, which is now at 70%. One of those is going to go to node 2, which is now at 70%. And now it's going to schedule a 40% pod that goes to node 3, which is now at 90%. But now the fourth pod can't be scheduled because no node has that amount of resources available.
Mm-hmm.
If I schedule the 40% pods first, I can, node 1 now at 90, node 2 now at 90. Now I've got node 3, which is at 50, and I can schedule the two 20s to that one node. Everybody gets scheduled. Multi-stage scheduling would be able to take into account, so one, maybe we have something that's aware of that type of utilization or something like that. But let's ignore that type of scenario. Let's say that maybe we're at that 20-20-50 or 70-70-50 scenario. A multi-stage schedule thing could say, okay, well, if I move one of these 20% pods over to the other node, I now have enough capacity and they're surviving. So it's a multi-stage move one to make room for a new one type of thing. So nothing like that exists, but it is kind of an interesting type of scenario. Of course, if you have cluster auto scaling configured, when that fourth one tries to get scheduled and it can't schedule, that would trigger a cluster auto scale operation where it would add a new node to the cluster. So you wouldn't be completely out of luck, but it's also not an efficient use of resources, right? I'm adding a whole new node. I'm potentially having to pay, for AWS or Azure or whatever resources that I'm using, when it could be more efficient. And in theory, over time, using Descheduler and all those other things, in theory, it would probably work its way back to that optimal situation. And then, hopefully we would scale down the cluster. But in the short term, that's additional resources. So that was an interesting question that I posed to that team, that they basically said, that's really cool, but we can't do that today. All right, let's see. Hope9 asking if we have some tenants that put requests and limits close to get guaranteed resources and use 5%. Yeah, I think what you're asking. Okay, I see what you're asking. Can I schedule while ignoring requests? I don't know if you can do that or not. That's a good question. I'll post that over, and I'll post that one in the gist in the markdown.
Mm-hmm.
But all right, so my laptop is safe for now. I did have to go over, if anybody is watching me on camera moving around, I did have to go over and plug into the wall instead of the table. But I think we are approaching the end of our time here. If anybody has any questions, anybody in the audience, go ahead and submit those in. We'll answer those as they come in here as I'm rambling through the closeout. If you're not watching us live, again, feel free to reach out to us. You can reach me via email, andrew.sullivan@redhat.com, or @practicalandrew on the various social medias. I also definitely encourage folks to use the Kubernetes Slack. So way back at the beginning here, Johnny, I think, posted a link to the Kubernetes Slack for the OpenShift users channel. It's a great way to reach out to us as well. And I'm Practical Andrew in there as well, I think. And you can reach out whether or not you're watching us live, or whether or not you're watching us after the fact. Anybody who's watching us live, you're welcome to reach out at any time as well. Again, we love topic requests and stuff like that, so don't hesitate to reach out. Let me switch over to chat, make sure I'm not missing anything. VPA is a way around that. Yeah, don't touch the deployments. You could also put in place a limit range, I think, if you wanted to prevent them from doing something like that. So set the limit range, create a limit range that maybe enforces a request at some level, so that way they don't have and they cannot create a request that's more than, say, half a CPU or something like that. Mm-hmm. That's not a limit, right? So they would still be able to use more than that. It would just prevent them from tying up unnecessary resources. So reach out to us, social media, Slack, all of the places. We really appreciate hearing from everyone. Chat is the main reason why we're here. We love chatting with everybody, so thank you so much. Next week we'll be talking. Where is it? Now I've completely lost my thing. Anyways, Johnny, I've got too many tabs open and not enough windows for them. Ignore me. I don't know what we're talking about next week. I thought I did. But yeah, so thank you, everyone. Thank you to our audience. Really appreciate you joining us today. Johnny, as always, it's been a pleasure. Rohan behind the scenes. So Stephanie's still helping out with us, but she has officially stepped back. She has other bigger, more important things to do here inside of Red Hat, which is awesome for her. But Rohan has stepped in and he's now helping us. So thank you for your help. We really appreciate that. And you'll be seeing and hearing more from him across various other streams as well. Yeah, that's all I got. Johnny, any last words?
No, this was awesome. Yeah, sorry about the demo not going, not working exactly as expected, but
Mine didn't go great either. It's okay.
yeah, it's one of those things where like I can't wait to get it working and actually see it in action because it seems like it's really cool, and the more I was messing with it and the more I was reading up on it, I was just like mind blown.
Hey, you want to do an experiment?
Sure.
We should create a YouTube short on it.
That's a good idea. We might do that. That might be what we do. It's a good idea, actually.
What's the worst that happens? It's only 60 seconds. There's only so much that can go wrong.
Exactly. Yeah, it's gonna be great. It'll be amazing. But no, yeah. Thanks again, Andrew. Like this was awesome, and looking forward to next week. I can't remember what next week is either, but I remember it was something cool. Anyways, we're getting old. But no, thanks everybody for watching, and make sure you like and subscribe on Twitch or YouTube or wherever. And yeah, we'll see you next week.